All right, sounds good.
All right. I'll turn my camera on for the crowd. Well, hello everybody. This is our last session of the 2020 Summer Azure Data Fest, our global 2020 Summer Azure Data Fest. So thanks for attending. We've got, I think we had about 250 at the height. We had, 600 RSVPs. You get some no-shows and all that. That's fine. Thanks for attending though, and we want to thank our speakers, proctors, and staff. And then if you need to go back and look at your event schedule, there's the link there. That'll be up and running. If you want to download speaker slides, go out to our download link and our YouTube channel to watch videos. And we'll have those over the coming days. We'll have the slides and the videos all prepped up. For upcoming events, we have a July 21st summer AI ML fest. It's, sessions around AI and ML. I think we'll have 4 or 5 tracks and similar to this, 10 to 3, that type of thing. Our next Azure Data and AI Fest will be held probably in the late fall. We haven't really decided on a date yet, but we'll announce the links when we get a date. And I just want to thank everybody for speaking. I want to hand it off to Jake Switzer. He's going to talk about building an NFL scouting dashboard with Azure Data Services. So without further ado, sir, I'm going to hand it over to you.
Cool. Thanks, Tim. So I'll go ahead and share my screen.
And I'll stop sharing. Cool. And I'll be online for Q&A.
Sounds good. Let me go back in here. And we're good. Yeah, so hey, everybody. So thanks for sticking it out this full day. This is the last session of the day for the conference. So I wanted to have a fun topic to show all the different technologies that are some of the cool technologies within the Azure Data Suite. How you could create a cool little end-to-end solution, for learning and for actual demo purposes. As Tim mentioned, I'm Jake Switzer. I'm a cloud solution architect at Microsoft. I solely work with our sports customers. So the NFL is a customer that's near and dear to my heart. So I actually built this demo for their tech conference last year, and then enhanced it some for some of the teams this past spring, or I should say this past winter, before we kind of shut down travel for COVID. So with that, I want to keep it very free-flowing, so feel free to ask questions throughout. I'm going to have a few different services that I'm going to have running, so definitely don't feel like you have to wait until the end to ask questions. So with that, I only have a couple of slides, and I wanted to give just a brief overview of what I'm going to be showing and what the reference architecture looks like. So very simple reference architecture. And it's really meant to just show, hey, this is how we can use Databricks to grab some quick data sets, load it into Azure SQL, report off of that in Power BI. So very quick, easy flowing sort of solution. The solution itself is around NFL scouting. So there's a lot of data on the internet around the NFL scouting combine, which is where players, athletes that are draft eligible, they go show off their talents. So how fast they are, how strong they are, hand-eye coordination, all of that good stuff. And then also their stats from their time in college. So putting all of those sorts of metrics together, NFL scouts can then go and make an informed decision on who they should invest in on their respective teams. So with that, I wanted to show how we could use a couple of packages in Python and with the power of Spark to scrape a lot of these different websites that have these data sets, load this data into SQL, and then create a pretty cool little dashboard in Power BI. So So with that, it's it's a lot more nuanced features of each of the individual products that may not stand out upon initial usage. So with that, let me actually jump straight into my Databricks notebook. So let me get over there. Cool. So this is, for those of you that don't know, this is the Databricks workspace environment that gets spun up whenever you create a Databricks instance on Azure. So when you go into it, it takes you back to this Home tab and gives you a lot of options around writing Python notebooks, R notebooks, Scala, Spark SQL, etc., standing up your own cluster, all that good stuff. So with that, so I have a few different notebooks that I'm actually going out and using to scrape websites. Now the package that I'm using to scrape NFL Combine results, so this is the website here, is the Beautiful Soup package. So it's a library, or it's an open source library in Python that allows you to scrape data tables on websites. So if you're familiar with web scraping in Python, you're usually going to use Beautiful Soup for simple tables because it's pretty quick and easy to use, or Selenium to go through and scrape websites if you're trying to create like a shopping cart and you're going through Amazon and you're going through multiple pages. You'd usually use Selenium to start scraping things. But for this example, I wanted to use Beautiful Soup because I'm pulling directly from a table. Now, before I can actually go on and start writing code and using these different libraries such as Beautiful Soup and requests, I actually have to add it to my cluster startup. So if I go into the cluster itself, so I'm using this JS cluster. So it's a simple Spark cluster with just a couple of worker nodes that I usually have spun up at the time, one driver, just standard VMs that I have up and going. Now to add the libraries after the fact, so I could have added them in init scripts upon the initial startup, but instead decided to add them afterwards. So you see Beautiful Soup and requests, and I can actually go into this install new, and since they're part of the Python sort of standard library, I can search for them in here. And upon searching, I can install them on my cluster. So these libraries get included in the cluster startup, so they get installed on each of the driver nodes that I get spun up with my cluster, so that the distributed Python knows how to actually go out and take advantage of those libraries. So if I go back to my notebook, so this is the first notebook in a gambit of a few different notebooks. So I have a handful of notebooks that I wrote for all this information. So for this first one, I'm really just looking to grab some of the information around what is the player's name, where did they attend college, what was the conference that they played in, all that good stuff. So, and of course, before I get into that, one of the things that I've done to parameterize how I go year to year to year is to create a widget. So a widget in Databricks is just a way to create one of these little drop down, and I can also have like a radio dial. The options are out there, but it's a way to parameterize my notebook so that I can use different options when kicking them off. And I'll show how we can dynamically kick these off in a second using Data Factory, so that every year after the NFL Scouting Combine, I don't have to come in here and run these notebooks. I can just have a Data Factory pipeline on a schedule, get kicked off, and run my or grab the newest batch of data. So with that, I am essentially just grabbing the parameter itself, the year. So this would be 2020. I'm inserting it into that website, and I'll show you what the website looks like here in a second. And then I'm starting to parse through the backend HTML to grab the data points that I want to load. So the website itself looks like this. So if you can see, we have a nice, neat table. So this is the 2019 data set. And this is all the combine results for each of the athletes that I have listed. So to take a quick step back to minimize the scope of my demo here, instead of going through each position that's included in, in a football game, I just did running backs. While I live in New York, I am a Alabama native, and I'm a University of Alabama alumni. We are known for running the football and known for having really good running backs. So this was the sort of data set that is near and dear to my heart, and one that I wanted to focus on. So a little bias there. So if I go into developer tools within this website, I can start to dive down into where the table is located. So I have this div, and I can go even lower into the table itself, and then I can start diving into the individual elements that have the data points. So here's the name, here's the school, all that good stuff. And Beautiful Soup allows me to essentially run through all of those different points, the specific points that I want to highlight, and then add those to a list. So I have this RB profile list. If I print it out, I have all of my running back names, the position itself. I wanted to include that in my database, and then the schools that they went to. And then I also, for a second table, am just pulling out the name, and this is the stats table that I created for their last year in college to grab the rushing yards, rushing touchdowns, all that good stuff. So setting all that good stuff up. Now, once I have all of my data loaded, then I can use Databricks to then push data down into SQL. Now, one of the technologies that I did not talk about in my architectural diagram was Azure Key Vault. So you can use Key Vault to store secrets such as SQL passwords, usernames, the database name, server name, all that good stuff, and never have to expose it in plain text to your notebook. So you can tie a Key Vault instance to a Databricks instance by essentially using this site. So if you go to your workspace, you'll have this website, and if you append the # secrets / create scope, then that allows you to go in and create a secret scope that's tied to an Azure Key Vault instance. And that allows you to then use Key Vault secrets within the context of Databricks. And so that's how I'm able to go in here and use all this good stuff to keep other people from being able to see my username, passwords, all my secret information. So once I'm satisfied with all of this, then I can start writing data to my database. And so the database itself is just an Azure SQL database. It's not a very large database because, again, I'm just going from the year 2020, so the running backs that were drafted this year, back to 2007. So 2007 was kind of a landmark year for the modern running back offenses started to change in the NFL. So it was easy to analyze running backs from 10 years ago and compare them to running backs now. Whereas if I'd have gone any further back, it would have been a little different. The style of play was much different 20 years ago compared to just 13 years ago. So this is the first notebook that I have. And this was a pretty simple sort of scrape. So I didn't have to make any sort of changes to any of the data that was coming in. Now, in the second notebook that I have, where I'm scraping the actual combine information, that's where I started to have to make some changes using some user-defined functions. So in this notebook, I'm grabbing all the metrics that a running back accumulates at the NFL scouting combine. So some of the workouts include the bench press. So it's how many times can you bench 225 pounds in a row. Their 40-yard dash. So it's just a 40-yard sprint. 3-cone drill. So this measures agility. And then the vertical jump and the broad jump, which essentially measures how powerful their leg strength is. So for running backs, this is more important because as they run the ball and they hit the hole, you really want somebody who has a lot of power in their legs to get a lot of that churn and get those extra yards. So these are some of the more important metrics when it comes to scouting running backs. And so that's why I focused on these metrics when I did my scrape. Now, one of the things that I noticed that I thought was very interesting, because some of the football players, they have the option of choosing which workouts they want to do. So you see some of the athletes, they didn't do anything at the scouting combine. Some of the athletes just picked and choose. So Ronnie Anderson in 2019, he only did the bench press. So there's a lot of nulls that popped up throughout the data set. So when I scraped the data, one of the things that I noticed was that anything that was a null came back as, or any of the fields that were doubles. So the 40-yard dash is measured in decimal points. The 3-cone also in decimal points. Vertical and broad jump is whole numbers, so didn't have any issues there. But with the data points that had decimal points, anything that came back as a null got replaced with 9.99. Not sure why that happened, but it was a very interesting find. So to eliminate that issue, I created a user-defined function that essentially uses a lambda function to rotate through each of the numbers. If the number itself is 9.99, return null. Otherwise, just keep the number as is. And so when I create my Spark data frame with all the relevant data fields, I can then go through and alter or do some quick transformations to get rid of the 9.99, and then I get my null back. So just some quick transformations here, nothing crazy, right? And once I'm done, I can load those into a table in Azure SQL database. So all of these are within the same database as the previous notebook, different table because I'm doing some more, more relationships, more joins with that sort of information. So let me actually skip this one for now and go down to measurement. And so measurement is just height and weight. So all of this information is in inches and in pounds. So that's why I get back 71 inches, 196 pounds, all that good stuff. And I actually take, so in a second, I'll show how you can use T-SQL when you're importing this information into Power BI to change that to actual feet and inches measurement. So it's a little easier to read in your dashboard. So with all of the scraping done, I can then very quickly move all of that data into SQL and have it set up and ready to go for some more transformations and some more analysis. Now, right now, all of this is done manually, right? So I'm actually, going through and going through each cell, hitting Shift Enter, Control Enter, or running the entire notebook all at once to create my to create these data sets. Now, what I can do instead of doing all this stuff is set up a data factory pipeline that's connected to these notebooks and kick off these jobs every year after the NFL scouting combine is done. Now, with that, let me actually go to my data factory instance. So very, very simple data factory pipelines, nothing crazy. You can definitely set up a job within a Databricks or within Databricks instead if you're just going to be running these notebooks. But for the sake of the demo, I want to show how you can set up a pipeline within Data Factory to kick off a Databricks notebook. So these are the 3 Databricks notebooks that I want to run after the NFL scouting combine, but before the NFL draft. So I can actually go in here. I have a Databricks notebook task. I can drag that over, and then to tie it. So I have my link service. If I want to create a new one, I click new, or if I want to edit it, I can click open. So all of this information is within the context of my Azure subscription, or an Azure subscription that I tell it to point to. I get my workspace URL from there, and then an access token. Now to create this access token, I can actually go in here to user settings and generate a new token. And so this token can then be used to tie a data factory pipeline back to Databricks Notebook, so I can easily run the Databricks Notebook within the data factory pipeline, and then I don't have to deal with any other issues there. So this is. Let me give this a little bit to go away. Or let me do this. Yeah. So once that is done, then I can also, if you remember what I mentioned earlier about the widgets, I can actually pass a parameter from Data Factory to that widget in the Databricks Notebook. So if I create a new parameter, I can name it year, and then I can actually use this function to grab the current year because that's all I want to do every year because of the way the website is structured. I just want to grab the current year and then append that within the website. And so that's how the Databricks Notebook knows to go to the website for the current year to grab those stats. So not a lot of extra work there, and a pretty fun way of kicking off notebooks. Now with that, I'll show in a sec the way the dashboard looks. But one thing that I wanted to note before moving on was that I do have an additional notebook for the information that's gathered after a player is drafted. So if I go to this draft selection, so I actually have a different website, ESPN.com, draft positions, etc., and then the year itself. So I run this notebook after the draft is over to grab the draft pick, to grab the round that player was drafted, all that good stuff. So you see I'm using the same package, Beautiful Soup, grabbing all this relevant information. So from this past year, for example, Clyde Edwards-Helaire out of LSU was drafted in the first round and the 32nd pick overall. So this second number is the draft pick in context of the round that they were selected in. So DeAndre Swift was drafted in the second round, and he was drafted the third pick in the second round. So that's how I'm grabbing that information. So yeah, and so one of the things that I wanted to do was, maybe the round number itself, not very intuitive if you're building a dashboard out of it. So I wanted to change it to the respective name itself. So where the round is 1, change that to first, round is 2, change it to second, etc. So I can use or I can build a new data frame off of my initial data frame with the altered information. And so I can do those quick transformations. Once the transformations are done, I can then push all this good stuff down to my SQL database. Now, one thing to note is that the database I'm pushing, or the table that I'm pushing this data down to, is my staging table. There's a couple of reasons that I have that. So in my SQL database, let me go to this. So in my SQL database, I'm creating player IDs using identity columns, creating some foreign key relationships between tables so that all of my different tables can talk to each other when I do my reporting. And all of that gets done initially when these first sets of notebooks get kicked off. And these notebooks, because they're kicked off before the NFL draft, are all in alignment with how the structure of the table should be. Now, my second pipeline here is specific to the notebook that's for the running back draft selections. And so this is done after the NFL draft, so it's done a couple months after all these other activities have finished. So there's some things that need to occur. So one is that I'm updating the player ID. So within Data Factory, I can include stored procedures that are located on my Azure SQL database, and then I can kick those off directly after my notebook runs. So with Data Factory, it's a pretty cool way to daisy chain activities together so that you can run things in a sequential order, so you're not having to do a lot of manual activities. So the first one updates the player ID, and then the second one actually performs an activity that pushes data, and I'll show that stored proc really quick. Oops, so I must have canceled out of that. So let me talk through it while it's opening up. So it's essentially saying, okay, so I have a set number of players that participated in the NFL scouting combine. Some of those players may not have been drafted. There's only 7 rounds in the NFL draft, 32 picks per draft for each of the teams. And there's a lot more running backs than there are 250 some odd picks that get left out. So instead of completely leaving them out of my data set for my dashboard, I want to take those values that are null, where they're not picked at all, and change it so that there's a not drafted field in there. So let me go to my programmability, store procs, and just do a modify. There we go. Yeah, so I'm essentially saying in my draft selection staging, if the field is null for the round and for the pick, just change it to not drafted whenever I push that over to my primary table. And so that's the stored procedure, how that's running. So pretty quick activity there. Now, once I have everything set up in my database and I have my table structured the way that I want, then I can start creating some pretty cool dashboards. So this is the dashboard that I created within Power BI for the running back scouting. Now, essentially, what I did, if I go up here to transform data, I have a couple of tables in here. The first one comes from my SQL database. And instead of just going through and picking individual tables and all of that, I used a query to pick exactly what I wanted to pick for my analysis. And so I mentioned earlier, I know it's a little small, let me know if you can't really see it, but instead of pulling in, for their height, just inches, I wanted to do a quick calculation that gave us the height in feet and in inches in a format that makes a lot of sense to scouts. So I have this quick formula that goes in here, creates the height in feet, a tick, and then whatever the remainder is by 12, use that as the inches, and then a quotation to make it very friendly for anyone to check out. And so, as you can see, I'm using a couple of tables. One thing that I didn't mention earlier was that yards and attempts were a little harder to pull in via Beautiful Soup. So I actually went through and used SQL to pull those in. There were some athletes that, while they were listed as eligible for the NFL draft, they had no rushing yards and no rushing attempts in college, which is a pretty easy indicator that they probably are not getting drafted into the NFL. So I decided to eliminate all of those players by using this where statement and just have the relevant players within the dashboard. And then I also created this quick images table. So each of these images I just grabbed from their Combine website. So NFL.com has headshots of all the football players that come to the NFL Combine. So that's where I just went through, scraped that, and added those images into my Power BI table. So I could have a nice, neat view of each of the athletes that I may be scouting. And then I had this top running back flag. So each year there's multiple lists that are put together around who are the top 5 players at their position for this draft class. So I included that flag in there to have a little more information so that in my dashboard, I can show just those sets of players, that those are the only guys that I'm looking at. So with that, let me go back to my dashboard.
Jake, there's a question it says, how much does the process cost to run for the running back and the running back data set for Databricks and Data Factory?
So for Databricks itself, now the cluster that I'm using, because let me go back to it. So because the data set is very small, so each run may only grab, I don't know, maybe 100 rows of data. While the cluster that I'm using is a pretty generic cluster, I could scale it down to a one node cluster that's as cheap as it can be. There doesn't need to be a lot of horsepower here to actually run what I'm doing. One of the reasons I use Databricks for this example, because you could definitely use like Jupyter Notebooks or another Python IDE for that. I wanted to be able to mess with Databricks in a small low cost environment, so with a small cluster, and then use data frames, use some of the PySpark capabilities, because PySpark transformations and native pandas, or so pandas being the data manipulation package of choice for most Python users, there are some differences. So this was a way that I found that was very easy to test and to try out those different things. The data factory pipeline, like I mentioned earlier, I just run it once a year, and that's or I should say twice a year. Once after the NFL Combine and once after the draft is finished. So I don't know the exact cost, but it's a very small number. Cool. Any other questions before I go back to the dashboard, Tim? I'll take silence as a no. So I will go back in here. So yeah, so like I mentioned earlier, so I brought in my data all from SQL, and then I started putting together some different tables and some different visualizations to show, what the running back sort of their stats from college and their combine performance, what that sort of looks like. So I use a table here to grab just the combine information. These are just the top 5 running backs from the 2020 draft class. So I just have their information in here. So their height, as I mentioned, I changed to a more friendly format. Their weight in pounds, 40-yard dash time, bench press, 3-cone drill, vertical jump, and broad jump. And then I also have a couple of visualizations around how they performed in college. So like J.K. Dobbins had 21 rushing touchdowns his last year in college. And then he also had a little over 2,000 yards rushing and a little over a 6.5 yard per carry average per attempt. So if I get rid of that, you may be wondering, hey, Jake, there's a lot of information here in your Power BI data set, and I put all this good stuff in folders. So where is a lot of the slicers that could be used? So I want to give a special shout out to the Guy in a Cube YouTube series, and specifically Adam Saxton, because there's a really good video around how to create a slicer pane to hide slicers without having it just clog up the screen. So I have this little hamburger icon, and this is just an icon that I downloaded from the web. But if I click Control Enter here, give it a little bit of time. Oh, there we go. So you see all of my slicers that I may want to use to slice my dashboard. And so I have a button here to go back. I have a block. So if I go to Insert, I can insert a quick shape, and then I can overlay all of my custom measurements, all of the stuff that I want to filter by. So at the draft class, and let me actually get rid of these. And so giving it some time. And so if I want to go back to, let's say I want to compare 2007. So I have Adrian Peterson, Marshawn Lynch, and actually let me go to 2008. Because that is Chris Johnson. And I'm actually doing it so that the 40-yard dash, so lower the better. The faster players come up first, and then let me compare them against 2020. So I have a few different visualizations in here, or a few different slicers, I should say, that are custom measurements that I built with DAX. So top running backs by 40-yard dash. If I go in here into this folder, if I click on it, you can see the DAX. So all I'm doing in here is I'm ranking the top 5 running backs per class by 40-yard dash. And because it's the lower number comes first, I'm flipping it, so saying the ascending in here, and then grabbing that. So if I actually say yes, then I grab, so Jonathan Taylor was drafted this year, Darren McFadden, Chris Johnson was drafted in 2008. And so I can start comparing, hey, how did these running backs, because I can take information, Chris Johnson, Darren McFadden, they've been in the NFL so long that they have now retired. So I can take a look at their stats over the years and compare and contrast running backs that are coming out of college now to think, okay, how do they fit in my system? How are they going to get drafted? All that good stuff. You can start creating some fun games, as just a fan that may even be fantasy football related. So you can grab all that information. And so let me actually, oops, gods. Let me actually go back. And so with that, let me actually show you really quickly. And I have the link to the slicer pane video that Adam Saxton put up. But a lot of that is done through the use of bookmarks. So if you create a bookmark, no slicers, and a bookmark is just like a snapshot of what is on the screen. If I go to slicer pane, then that's the bookmark that's there. And again, I'll share the link to Adam Saxton's Q video where he goes in depth about how to create the slicer pane. Thought it was pretty cool and a pretty easy way to hide all the messy stuff on the screen. So one of the other things that I want to do before finishing up my Power BI dashboard and publishing it to the web was to take advantage of some of the out-of-the-box features of Power BI to create quick machine learning analysis. So if I go to this Key Influencers page, so this visualization right here is called the Key Influencers Vigil. So it's shaped like this. And essentially what it allows me to do is take a feature and then explain what attributes that I have available or that I want to give to the visualization, explain what is their relevance to it. So in my case, I want to see who or what attributes affect a athlete being a first round draft pick for running backs. So when I add all of these different features into my explain by field, then I get this. So if their yards per attempt, their last year in college was more than 5.5 yards per attempt, they have a higher chance of being selected in the first round of the NFL draft. Makes a lot of sense. If their yards per attempt is pretty high, then they're probably pretty good. 40 time is less than 4.5. Makes sense because they're pretty fast. Class is junior, so this was one that So when I say class is junior, so as a football player, you're eligible to enter the NFL draft after your 3rd year in college, whether that be a redshirt year, so this will be a redshirt sophomore, or you're a junior in college. Now, of course, there's a lot of seniors that go on, but there's a higher chance of an athlete getting drafted in the first round if they're a junior. For running backs, that's mostly because if you're a junior and you're skipping your last year of college, you're probably pretty good, and it makes a lot of sense to go on to the NFL and get paid. For running backs, it's also pretty important that there isn't a lot of wear and tear on their legs because just over the course of time, age affects running backs more than other positions. So the less wear and tear that they get in college, the better chance that they have of having a solid career in the NFL. So they're one of the top running backs by 40-yard dash. Cool. Yep. And then we go down to my favorite stat down here. So as I mentioned before, alumni of the University of Alabama. We are in the Southeastern Conference. So according to my analysis here, and this is according to the stats and to the data, if you're an athlete that's coming out of the SEC or a running back that's coming out of the SEC, you have a higher chance of being a first-round draft pick than any other conference. Now, that's not a bias. This is the data, so you can take it however you would like it. And pretty cool thing about this visualization is that because it's a native Power BI visualization, it works well with any of the other filters. So if I have a filter here for conference, I just want to look at those running backs in the Big Ten, then I can start poking and playing with that. So pretty cool stuff. And then I also included a natural language query text box in here. So I actually have a question. So let's say that I know that defenses in the year 2020 are, maybe a little bit more lax on the running game in different conferences. And I want to just test that hypothesis by quickly using just natural English to pull that out. So if I want to do total touchdown by conference for the year 2020, I can grab that and I can start looking at how many rushing touchdowns were there in each conference, and then start breaking down like, hey, maybe this conference is a more run heavy conference, and I should analyze a athlete coming from these conferences a little different than others. So I can start create some pretty cool stuff with just natural language stuff. Now, another quick point. So let's say that, so for my example, I was demoing this to a couple of teams, and I wanted to show how to use row level security. So let's say that I have a scout that only scouts players that come out of the SEC. He or she doesn't deal with the Big 10 or the Big 12 or any other conference at all, so doesn't care about those. Then I can actually go in here and create a role to create a little more security. So I'll show in a second how you can go into Power BI Online, add different users to some of these different roles so that user only has the ability to see SEC players. So let me actually go back in here and let me open it up so that there's more players. And so if I go view as, I do SEC Scout, click OK. Then, right, cool. So all of these athletes, so DeAndre Swift went to Georgia, Keyshawn Vaughn went to Vanderbilt, and so forth. So I can't remember where Rico or Scotty went, but I know Clyde went to LSU, another LSU guy, and Florida. So it's just pulling back the players that went to SEC schools, and shows pretty quickly how I can set up row level security so that different users can just see the players that they want to see. So once I'm satisfied and done with my dashboard and all the good stuff that I want to do, I can publish it. So if I hit publish, then I can, let me hit save. And then I can select a workspace to deploy to and get it going. So let me actually go back in here and show it. So this is the workspace that I have, the sports demos. I have my report. So I can start going in here, selecting and filtering by all the good stuff that I just showed, and all these different filters and slicers. So pretty quick way to create a good holistic view of running backs that have been drafted and that are being drafted, so that I can either as a scout them, or as a fan maybe create some fantasy football bets and gambling odds for the upcoming season. So like who's going to be the offensive rookie of the year and all that good stuff. So yeah, so with that, so one last thing too. So I wanted to show how I can enable the security role that I built on Power BI Desktop. So if I go in here to data sets, I hit the ellipses and I go to security, then I have my SEC Scout, and then let's say I want to add just myself, I can add myself as a member or a security group. This is all Azure Active Directory integrated. And I can add external users to it. So I can start adding different users and groups to this role so that they only have views at the data that's specific to them. So with that, I have come to the end of my demo. Let me go back to these slides really quickly. Let me switch the display settings. So yeah, so like I mentioned, just a quick and easy way of building out a solution within Azure to create a cool data set. Or it's a data set that's near and dear to me. I'm a big football fan, but it shows that you can, no matter what you're a fan of, if there is data out there, and I'm sure that there is data out there somewhere, right, on the web, you can scrape it. You can use Databricks. You can use Azure Functions, however you want to kick it off. And then use Data Factory to orchestrate it, store it in a data store of choice. For me, Azure SQL made a lot of sense, and then report off of it using Power BI. And using some of the more nuanced features like using DAX or using a slicer pane, you can create a pretty visually appealing dashboard really quickly for fun or for demo purposes at work. So with that. So I have all of these references and links. The slides will get posted after we're done here. So you feel free to go in and check out Adam Saxton's video on building a slicer pane. These are the NFL Combine results that I showed earlier, and then the documentation for Beautiful Soup. So all of that is available as well. And definitely feel free to reach out to me on LinkedIn. I unfortunately was not the first Jake Switzer to create a profile on LinkedIn, so I have this nice ugly set of digits in front of my name, but don't hold it against me. I am the only Jake Switzer that I know of on LinkedIn with a beard in the picture. So if you see that guy, then that's probably me. So yeah. So with that, if there are any questions, feel free to ask.
Throw them out there, folks. Let's see if there's any Q&A for Jake. So I'm a Seminole alum. I'm an FSU alum, but
Nice.
I was raised on the Alabama campus up until the age of 4 or 5 at the married student housing.
Oh wow. Okay.
Yeah, my dad graduated from Alabama, so I'm more of an Alabama football fan than anything else.
Well, roll tide. Nice.
Roll tide. I got an Alabama gnome out my front door. I'm Alabama.
That is awesome.
Roll tide.
Nice.
Yeah. Oh, sorry, we're giving a technical session. Well, Jake, I want to thank you very much. It doesn't look like there's any questions. Thank you very much for a good, informative session. I like the data set that you use to sort of bring it to life and make it more fun. I really appreciate that.
Of course, thanks.
All right, everybody, go have a good 4th of July weekend. Jake, you have a good 4th of July weekend, and we will see you guys at the next event. Thank you very much.
Cool. Thanks, y'all. Everyone have a good one.
Bye-bye.
Bye.
Stop.